Hello, let us look at the production of microbial production of organic acid. So we are looking into the production of acetic acid and citric acid. So acetic acid, more the vinegar, for on the acetic acid we will be learning about the production of vinegar. So what is vinegar? Vinegar is solution that is containing more than 4% of acetic acid. But so vinegar, the content of vinegar will be more than 4% of acetic acid, and it is also called as sour wine. Why? Because first vinegar was produced by the oxidation of wine. The people, they kept the wine open. The wine was kept open, so the wine was spoiled and it became sour in taste. Okay, so it occurred by natural oxidation. The wine bottle is kept open and it is coming in contact with the oxygen in air, and due to oxidation the taste of the wine is changing and it is becoming sour. So, and whatever that was produced, that is vinegar. So it was initially called as sour wine. And we can classify vinegar into different types based on the source of vinegar, or based on from what it is produced. So if it is produced from the juice of fruit, it is called as cider vinegar. So if it is from apple, we call it as apple cider vinegar. From if it is from starchy vegetables like potato, sweet potato, etc., it is called as starchy vinegar. If it is from malted cereal, if the starting source is malted cereal, it is malt vinegar. And if it is produced from spirit, alcohol, or alcoholic waste, it is called as spirit vinegar. So how does the acetic acid production or vinegar production occur? It occurs in two steps. Okay, the very first step is a conversion of a sugar into ethyl alcohol. Okay, and in the next step, this ethyl alcohol is converted into acetic acid. So we know that alcohol production, what is alcohol? Wine production. You're having a sugar source. It can be malted barley, it can be any fruits, grapes, etc. And this particular sugar is converted into ethanol, ethyl alcohol, by the action of yeast. Okay, and this step is common for acetic acid production also, and this particular alcohol is then again converted into acetic acid by oxidation. So the two steps are carried out by different organisms. So Saccharomyces cerevisiae carries out the alcohol fermentation, and Acetobacter or Gluconobacter helps in the formation of acetic acid from alcohol. So looking at the process, fruit, barley, honey, or whatever source is there, it is converted into ethanol. And the ideal content of ethanol, alcohol content, is 10 to 13 percentage. And from this, the supernatant of the fermented alcohol is taken. Whatever lefted fruit uh, or crushed fruit or barley is there, it is left behind, and the supernatant is taken, and into the supernatant, mother of vinegar is added. So what is mother of vinegar? Mother of vinegar means the vinegar from the last batch. Okay, the vinegar that was produced in the batch prior to this batch. So it will be having the bacteria, vinegar producing bacteria, Gluconobacter or Acetobacter, plus a little amount of vinegar. So when you're adding mother of vinegar into the alcohol, it is helping to bring down the pH of the alcohol, slightly bringing down the pH of the alcohol, not too much. And it is the bacteria which is already growing in the vinegar, it is acting upon the ethanol and converting it. Okay, so this particular step, alcohol fermentation, is an anaerobic fermentation. This particular one is aerobic oxidation. So aeration, this uh, process should happen in good aeration. Okay, so in olden times they used to carry out vinegar production in very broad trays. So alcohol was placed in very broad trays, so that more surface area of wine or alcohol is exposed to oxygen. And vinegar production, there are two different approaches or two different methods for vinegar production. One is slow fermentation or the Orleans method, and then you have the quick method. So the slow fermentation, it takes several weeks up to a few months, like 3 months and all. So the fruit juice fermentation, proper fermentation of the fruit juice is carried out, and the alcohol content reaches 10 to 15%. And after that, this alcohol is then fermented in a wooden barrel, and this wooden barrel is given so many holes for aeration. So aeration is provided through the holes on the wooden barrel, and as the process is happening, as the acetic acid is being formed, the alcohol concentration drops to 1 to 2% and the acid concentration is keeping on increasing. Okay, since this is taking a long time, like several months, it is called as slow fermentation. Next, you have quick method. Okay, quick method is carried out in a setup called as a vinegar generator. So you can see a vinegar generator here, and in the vinegar generator, on the top of the vinegar generator, there are wood shavings or wood chips, and on this wood chip, the bacteria, acetic acid bacteria are present. So alcoholic liquid, so whatever alcohol that you want to convert it into vinegar, it is sprayed from top onto the wood chips. It is slowly sprayed on the wood chips, and aeration is provided from either side. You can see the setup, there is inlet of air. So there is good aeration, alcohol is being sprayed on the wood chip, you have the organism, and what is happening? The organism is converting the sprayed alcohol into vinegar, and the vinegar is getting collected below this setup. Okay, this is happening in a very good aeration system has to be there, and the temperature will be 25 to 35 degrees Celsius. So there are a few vinegar defects, that is vinegar spoilage of vinegar by cloudiness, discoloration, etc. Can happen, and this cloudiness and discoloration is normally due to the reaction with metals and salts of metals. Uh, Bacteria like pseudococcus can cause the darkening and cloudiness of vinegar. Then there is a particular organism called as a vinegar eel. This is a nematode, a small nematode, which is been specifically growing in vinegar. Okay, now we'll come to citric acid. So citric acid, we know that citric acid is produced in the TCA cycle, citric acid cycle. Okay, so this is a primary metabolite. Citric acid is a primary metabolite because TCA cycle, glycolysis and all is a normal routine cycle that is helping the organism to utilize the glucose. So citric acid, if you want to produce citric acid, more and more citric acid from an organism, this TCA cycle should be enhanced, and citrate synthase, if more and more of citrate synthase is there, citric acid production can be increased, and the citrate degrading enzyme should be reduced for the optimal production of citric acid from microorganism. So looking at the uses of citric acid, it is used as flavoring agent, it is used in chemical and textile industry, it is used as stabilizing agent, it is used in preservatives, etc. So how is the citric acid produced? The organism that is used for citric acid production is Aspergillus niger, Aspergillus clavatus and Corynebacterium. And the media for citric acid production is molasses, starch, potato, date syrup, cotton waste, etc. So for citric acid production, 12 to 25% sugar, mainly sucrose, glucose or maltose have to be added. So why is this much sugar needed? Because citric acid is produced by the metabolism of sugar. Like if there is high amount of sugar, high uptake of sugar will happen, and the metabolism by glycolysis and TCA cycle will be happening. So more and more TCA cycle is happening, then more and more citric acid will be produced. So in the media, there should be the presence of manganese, ferric ion and zinc ion, and if these trace metals are present, it is shown to increase the yield of citric acid production. And exogenous ammonia is also helping in the increase of citric acid production. So citric acid production is an aerobic fermentation, and higher oxygen concentration is shown to increase the production of citric acid. So it leads a very good aerated system. And the pH, the very low pH is helping in the citric acid production. So fermentation process can be done by surface fermentation or submerged fermentation. In surface fermentation of citric acid, the microorganism is grown as layer on the surface of the medium. Okay, and surface fermentation can be solid state fermentation or liquid surface fermentation. If it is going on the solid medium, it is solid surface fermentation. If it is on the liquid medium, if it is not mixed in the liquid medium, it is growing on the liquid surface, it is liquid surface fermentation. So what is being done? The spores of Aspergillus or the citric acid forming organism is inoculated in the solid surface fermentation. The spores are inoculated on the solid medium and it is incubated at 28 degrees Celsius for 80 to 100 hours. And as the organism is growing, the mycelia is growing, the citric acid production is happening. Okay, and on the liquid surface fermentation, the spores are inoculated on the liquid media. It is not agitated and 30 degrees Celsius. Okay, and then the mycelia is formed on the surface. It takes 7 to 15 days for the production. Then you have submerged fermentation where you are mixing the organism is going into the liquid. So the submerged fermentation is the most preferred method. It is happening in stir-tagged aerated bioreactor. At 20 to 25% of oxygen is needed, and the best mycelia is that is giving the maximal production is forked bulbous mycelium with aggregate or pelleted appearance. These type of organism, these type of fungus are giving the higher yield. So 250 to 280 hours of fermentation is needed, and 110 grams per liter, 100 to 110 grams per liter can be produced. So how is citric acid recovered? So after the citric acid production is completed, the filtration is done to remove the mycelia, and the mycelium is washed, because the mycelium will also contain, the organism will also contain some amount of citric acid with it. So the mycelium is washed, and then to precipitate oxalic acid, which is very similar to citric acid, and this has to be removed. So lime is added at a pH less than 3 such that oxalic acid is removed. And then now you have a solution of citric acid. So you precipitate the citric acid at 70 to 90 degrees Celsius at pH 7.2. And this citric acid is dissolved in sulfuric acid, purified by treatment with activated charcoal, and it is passed through the ion exchange chromatography column and finally crystallized to get crystals of citric acid. So this is the flow chart for the citric acid production by surface or submerged process. Okay, you're giving the nutrient media, you're giving in air, and for the fermentation to happen, you can, like, both the method is shown here, submerged and surface fermentation, and after that you'll separate the mycelia, filter, add lime, add sulfuric acid, activated charcoal treatment, ion exchange chromatography, crystallization, and then you can dry and store your citric acid. So that is all.